Hi, everyone. Thanks for joining us today. I see some more people trickling in, but we'll get started. Yeah, if you joined this webinar today, you must be feeling the pain of shipbuilding change. Luckily, that's why we're here. By the end of this webinar, you'll be able to sleep a little bit easier knowing that a few more strategies to get control and visibility over customer, production, or supply chain driven change, some techniques for making, reviewing, and tracking changes, both with and without a PLM, and also bite-sized takeaways for your team to implement as part of your change management processes. Most importantly, you'll be better equipped to minimize the risk of change on your organization. So make sure to submit any question you have during the webinar, and we'll answer them at the end of the event. Just to introduce ourselves quickly so you know who you're talking to. I'm Greg, I'm the Shipbuilding Solution Evangelist at SSI. I showcase our solutions, our success stories, and just highlight the future of shipbuilding in general. Today I'm talking to you from our headquarters at Victoria, BC.
I'm Simon Crook. Thanks, Greg. I'm Simon Crook and I'm a solution specialist at SSI, joining you today from Melbourne, Australia. Prior to joining SSI, I've gained around 15 years experience as a design draftsman and CAD manager. I've at some point worked on nearly all classes of surface ships, currently in service of the Royal Australian Navy. And Malay?
Yeah, thanks, Simon. I'm Malay Pal. I'm based in New Delhi, India. I've been working with the shipbuilding industry for more than 25 years in the areas of design, construction, and data management. I've worked with many of the major shipyards in the world across all the three geographies. And one of my responsibilities in SSI is also solution consulting in the areas of PLM.
So change is a huge risk. I think we all know this, and especially you and your teams know this better than anyone. But it's not just you. Change accounts for over half, or for almost half of all schedule slips. But why can't we just avoid change? And why does the shipbuilding industry have to deal with more change than any other manufacturing industry? Unfortunately, it comes down to the realities of shipbuilding. There are milestone payments and financing realities where you have to hit certain deadlines to get paid. There are long build times. The design of complex products like ships continuously evolves during all of design, construction, and operations. The concurrent design, engineering, and construction of ships also means we can't avoid change. Naval programs especially have very long design build cycles, and change occurs continuously throughout it. System obsolescence is one of the key drivers there. But since you've already moved on to the next stage, any change has a huge knock-on effect. And lastly, each ship is unique. Every ship can be considered a prototype, unlike in other manufacturing industries. Even among ships of the same class, no two are the same, and it can be difficult to keep track of what revision applies to what vessel. This is something Simon will touch upon later in the presentation. So what types of change are we dealing with, and what are the associated risks? We have customer-driven change, or design change. We have production-driven, or change that are made to modify the product for ease of production. We have supply chain-driven change, where equipment specs can change or some supplier is no longer able to provide you with a part. So what are the associated risks? The risks of those types of change is that change can result in unidentified change propagation. For example, changing a pump can affect the local structure, the pipe routing, the power supply. If you consider sister ships and configuration management, not everyone is informed of a change or how it impacts them. Changing one component requires something else to change, et cetera, et cetera. This is even more true for complex naval projects. Malay is going to touch more about the role of information management, how we can manage this risk of change propagation. You have the risk of silos forming. Silos happen in shipbuilding because of numerous working disciplines all having to work together, different IT systems between you, your teams, and your contractors, poor system integration, conflict between departments, even cultural differences between organizations can result in silos and a lack of collaboration. Delays. Delays happen because of siloed operations. They happen because change takes time. All of this means that you result in cost overruns. This is what inefficient change management ultimately leads to, both for the shipyard and throughout the operational life cycle of the vessel. Now, I just quickly wanted to gauge how change data is or isn't available within your organization, just so we're all speaking on the same page. So if you see a quick poll in front of you, make sure to fill it out so you can have a better understanding of how change management data is available within your organization. Just a few more seconds here. I see some interesting responses flowing in, interesting results. So 60% of you could say that change management data could be manually made available across your organization. That's an interesting result. So let's compare how this sample size did with our assessment of shipbuilding industry leaders. So this is from our digital assessment. We did this last year with a group of shipbuilding industry leaders. At that sample size, only 45% said change management could be manually made available. But right now, what's even more interesting is that less than a fifth of shipbuilders have change management data consistently available as part of an automated process. And even worse, almost 20% of organizations don't have any change management data at all. So in a lot of ways, you guys are doing better than you think maybe. So what are our antidotes to this change risk that we just talked about? Well, the first one is getting control and awareness. Control and awareness is the key to minimizing risk from unavoidable change. And it means getting the right information at the right time for the right team. For example, purchasing will want to see a BOM list of all the parts created, deleted, and modified, along with all their corresponding attributes. The weight engineer will want to see a list of parts per SWIBIS that was created, deleted, or modified. The production floor will want to see the changes to the shop floor documents and any corresponding CNC files. And other departments will want to see a 3D visual of the parts that have changed so that they can quickly understand the impact of their change on the activity. We need to capture a plan for the required change. Understanding what change needs to occur removes the need for never-ending clarification and back and forth. Engineering has a clear picture of what needs to be done when you have this plan. When Simon mentions using tasks to manage change, remember this idea of control. And we need to minimize disruption to normal processes. Nobody wants to or should have to do extra work to manage change. Keep it simple. Forcing individuals to keep track of what they changed, let alone what they changed per hull, is a recipe for disaster. Using automated change tracking that is action-free for the designer is one way to free them up. And watch out for Simon to touch on that as well. We need to look at incremental and validated improvements. Focusing on MVPs and proof of concepts reduces the risk of innovation or implementing innovation. You'll know the project hit the mark when it is deployed. It's proven to solve what must change and is tied directly to solving one or more specific business objectives. This is a resource from Eris, one of our platform partners, and it had some more great information on this idea. So I recommend you check it out. Just if you Google that term, you'll be able to find it. And lastly, another antidote to change risk is information integration. Part of this is the ideas of platform of platforms. So establishing an information foundation that connects to all the other information and platforms within your organization. All of this is in supporting your goals and achieving them. Information integration lets you create one change and disperse it across multiple hulls. You can automatically and intelligently do this if your systems are all working together and your platforms are connected. Ultimately, this keeps the amount of rework down to a minimum. And lastly, change needs to feed the entire organization. By integrating with the systems already in place, the delivery of information is invisible to everyone. And our open platform approach means that every department is aware of what, when, and how a change will impact them, and then they can act accordingly. When Malay speaks to the role of an information platform, or PLM, for change management, it's because achieving this goal is so powerful for the organization. So now that I've given you a bit of a preamble, I'd like to hand it off to Simon to show how these strategies can be applied in the real world.
Thanks, Greg. Before looking at an example workflow, let's look at the degrees of difficulty when managing change throughout the project lifecycle. Change can be easy, but as the ship progresses through the design, build, and maintain phases, it becomes increasingly more difficult. When working on the initial design of a ship, designs haven't been released yet. Comprehensive management is not required at this stage. Designers have the freedom to make changes without the burden of process. They can simply perform a local clash check, find a mistake, fix it, all before the block is released to production. Once several blocks have been issued for production, we may get a late design change. The documentation will have already been released downstream and will need to be updated and reissued to the relevant stakeholders. This includes procurement, production, and the classification societies. Then we have the initial design for the second vessel of class, where the original hull is used as the baseline for the first of possibly many sister ships. In this case, when we make a change to the second ship, we need to decide if those changes are also applicable to the original ship. Often when building a class of ships, the first ship will only be half built when the yard starts cutting steel for the second ship. Any changes made to that first ship, such as production-driven changes, will need to be seamlessly incorporated into the sister ships in the class. Finally, the most challenging scenario, managing the configurations of multiple hulls. Multiple sets of drawings have been issued. The changes may need to be incorporated of some of the sister ships, but not others, and sister ships may have different configurations affecting the change. Because of the different configurations, some ships may require supplementary changes compared to the baseline ship. The downstream impacts all need to be understood and tracked. To overcome these challenges, we need to reuse existing modelling work and incorporate changes and improvements to follow on ships. In the example here, the circle change made to ship 1 is applicable to all the ships. The blue square change made to ship 2 is applicable to the follow-on ships. The triangle change made to ship 3 needs to be made to ship 1. However, because the square change affects the arrangement, the triangle change require supplementary changes. The typical workflow for the change seems simple enough. The problem is usually identified in a problem identification report, commonly called a PIR. It may have originated from customer request, production department request, from the supply chain, or following a design review. An engineering change request, or ECR, is placed by an initiator. The initiator could be the customer, engineering team, or anyone else involved in the product development. The ECR refines possible solutions and decisions regarding the change. Following a design review and approval conducted between the design authority and review board, a solution is proposed and documented as an engineering change order, commonly called an ECO. Once the ECO, or ECHO as we call it in Australia, is registered, the changes can be executed. The change could be registered using an ad hoc process such as spreadsheet, access database, other disconnected process, or through a PLM system, which Malay will take us through later on. When completed, the change may need to be transferred and replicated to sister ships in the class. Problems usually occur when designers use disconnected processes. While it may seem like a simple enough change will have flow-on effects. Greg gave a simple example earlier where a new pump being installed may require pipe, electrical and structural changes, and those changes may have flow-on effects to nearby equipment. This means different models, drawings, nests, bill of materials all need to be updated, reviewed, delivered and carefully managed. Ideally, there will be a single source of truth for manufacturing information, or documentation will need to be updated individually. Today, I'll be demonstrating making a design change to the sister ship and managing that process. In the example, the drill feeders on this 80-metre anchor handling tug need to be repositioned inboard to improve performance based on the sea trials of a previous design. Once reviewed and approved, the changes will be transferred to the sister ships in the class. This includes model changes, drawing changes, and updating the bill of materials. I'll be demonstrating this example without using a PLM system. PLM systems can systematically improve the way data is managed. However, it isn't the only way to improve how we manage change. With an understanding of how change flows through the organisation, we can identify the major causes of rework and make incremental workflow changes to improve the process. Before we begin making the change within the CAD system, I'll hand it over to Malay to discuss how a PLM system could be used to manage the change.
Yeah, thanks, Simon. So if you look at the shipbuilding industry, this industry has been early adopters of both CAD and ERP for past many years, at least 40 years for CAD. But PLM, or product lifecycle management, is relatively new in shipbuilding. What a PLM system does is supports the collaborative creation or authoring. By authoring, in this case, you're talking about, say, a CAD system for ship design, then management, which is managing the data, disseminating the data within the shipyard and to organizations outside the shipyard, and use of the product definition information, or in our case, the ship design and the manufacturing information across the extended enterprise. The extended enterprise would include the customer, class, the marine supply chain, or the specific marine suppliers, which could be even design providers for the project. PLM systems not only manage data during the design phase, they manage data for the entire life cycle of a product or a ship, starting from inquiry from a customer to design, production, or construction, in-service support and maintenance, then upgrades and refits, which is particularly important for naval shipbuilding, and right up to ship disposal. What a PLM system does is it provides a framework which effectively enables capture, representation, retrieval, and reuse of product and process data or knowledge. In this case, the process knowledge would be the knowledge for ship manufacturing or construction, and allows collaboration across distributed and multidisciplinary design teams in a shipbuilding project. Since shipbuilding is a project-based industry with heavy involvement of subcontractors and suppliers who are actually spread around the globe for most projects, effective collaboration is key for success of a project. And this is what a PLM system helps facilitate. One key requirement for effective change management is knowledge capture and retrieval for the current project and the foregone projects, which again a PLM system can handle very effectively. So a PLM system actually provides a digital thread for change management, which facilitates or allows a collaborative workflow that links processes across the shipbuilding organization. The organization for a typical shipbuilding project or a shipyard would include design, engineering, planning, production, and inventory, trust, suppliers, etc. If you look at the different scenarios talked about by Simon, as well as by Greg, they talked about sister ships, then different changes affecting a specific configuration of a ship and its roll-on effects, the effectivity of a change, which means which particular configuration and at what time should have that change affected, the required information or knowledge about a product and its current state to evaluate an engineering change is actually resident in different systems in a shipyard and multiple systems. And this is what a PLM system can help manage. If you look at the different change scenarios mentioned by Simon, we're talking about different configurations of ships of a class and how change propagates and affects different ship configurations, like the 3 examples we talked about, starting from design to manufacturing, and that can extend to ships in service. And then you will have different IT systems used in different places in the extended enterprise, and also importantly in different phases of the ship life cycle. So if you look at this particular slide, you see a major portion of the data related to the ship design or the product design is actually managed by the PLM system, which includes different configurations, different document revisions, effectivity. These are all managed by the PLM system. And the manufacturing data is actually managed by the ERP and MRP systems. So the PLM system manages the design-driven information or the product-related information and hands over or exchanges the data and information with ERP and MRP systems for production. So the PLM system enables the change to propagate throughout the life cycle of a product or a ship, making its real impact visible and measurable not only within the design organization, but also across manufacturing and other stakeholders across the extended enterprise. With this, I hand back to Simon for the demonstrations.
Thanks, Malay. back to the example, and here we see our 80-meter anchor handling tug within our CAD viewer. The drill feeders located roughly midships will be moved inboard and the interfacing structure and systems updated as required. To begin incorporating the change into our project, the engineering change order results in the creation of a ShipConstructor task within our CAD system. The tasks themselves can be created from the ECO, whether it was documented as an Excel spreadsheet, Access database, third-party PLM, or automatically from Shipbuilding PLM. Tasks are used to manage and track changes. Subtasks can be added to the ECO and then assigned to individuals or teams. For this change, the structural and outfitting teams need to be included. Tasks are an extension of how work is assigned to designers to execute a change order and a great way to manage and track changes throughout the project lifecycle. Work is assigned to individuals, teams, or even different organizations. Designers are assigned work to complete from their managers anyway, and capturing that assignment within the CAD system as a task should not be disruptive to an organization's procedures. Tasks can be used throughout the review process as a selection set. And throughout this demonstration, please keep in mind that tasks aren't just limited for managing change. They can also be leveraged throughout the design lifecycle. Next, we'll have a look at executing the changes. As part of this change, there are many flow-on effects. Connected pipe systems and impacted structure all needs to be modified. If the build phase has begun, production drawings will also need to be updated, although it is likely that changes will be reviewed first before drawing sets are revised. Design teams can work through these changes under the tasks they were assigned. As the changes are made, the work is captured and recorded under each subtask. Under each task, we can see the modifications to each part were captured, be it new, modified, or deleted. Changes are recorded at a part level, and a parts-based approach is important for a multi-hull project to simplify configuration management. In a drawing-centric approach, a single change in the drawing can affect tens of downstream activities and deliverables, which means the engineering team needs to repeat the product development process to incorporate this new information. In a part-centric approach, all product-related information like CAD drawings, documents, requirements, changes, etc. are logically related, and all users have access to the relevant product-related information at any given time, even as it evolves without waiting for updates to be released, which is inherent in a drawing-centric approach. This way, a part-based approach greatly simplifies configuration management. Next, we'll look at how the tasks and part tracing can be leveraged. Models and associated metadata can be viewed in real time for review. Load by selecting specific drawings, compartments, assemblies, units, part types, and more. We'll filter for the structural sections, mechanical systems, and the equipment in the affected area we need to see. Using the revision compare features, we can review the changes. Red for deleted parts, green for new parts, blue, modified parts, and yellow for modified parts from the original configuration. Turning off the original model shows only the latest configuration. Users can spotlight systems, assemblies, and parts they wish to review for clarity, or shown here, spotlight the work carried out under individual task set or subtask. Here we see in Spotlight the work completed under the first subtask. Part properties can be viewed in the Properties window. Different parts can be shown in different colors to help review. We can use the color by property command to differentiate all the different pipe systems shown in this model. Colors can be assigned based on any of the part properties within the product model. If we see a part that needs modifying, we can select it and switch back to the model to make the changes. Just to quickly recap on the workflow used, we chose to load the area relevant for the change. For a big change, you could view the whole vessel. We then compared the change to the existing configuration. In the case of sister ships, we could also compare the effect of a change on different configurations. Being able to load all the parts in the area of interest in real time lets designers visualize and understand the functionality of the design. We can do a virtual walkthrough of the ship, highlighting or spotlighting changes, systems, assemblies, or parts along the way. But what if we were reviewing the model through a PLM system? The video we just saw demonstrating a 3D review of the design can all be accessed from within a PLM system, shipbuilding PLM shown in the images here. Aside from viewing the model and model data, a PLM system also gives us the capability to mark up views of the model with comments, create a digital approval process, and track changes throughout the entire product lifecycle. Once approved, the documents and any requested changes are incorporated and can be issued for production. Once the changes have been approved, we need to intelligently pass those changes onto sister ships in the class. The changes to parts were captured under each task. We start by selecting the task, what we would like to transfer, and the destination product model. For this design change, we need to transfer parts, production drawings, nests, and systems. Before transferring, we can review a detailed list of the items to be transferred and automatically generate a graphic preview. After reviewing what will be transferred to the sister ship, we can begin the transfer. And the changes have now been made to the sister ship and a log file can be viewed. How are the changes synchronized with the sister ship? Well, their traditional analog method would be to identify all the affected drawings and manually update them. Fortunately, we can now synchronize product models by transferring changes at a part level. New, deleted, or modified parts can be transferred and the associated drawings, nests, and bill of materials updated. While completing the transfer, designers are notified of any warnings. Any parts conflicting with the sister ship configuration will be identified for resolution. The process I've showed is not limited to transferring changes by task. Entire systems or assemblies can be transferred between projects. While I've only shown this process used between sister ships, the same workflow can also be used as part of a multi-site or multi-organizational infrastructure. The updated product model and all associated drawings can now be viewed in the PLM system or CAD viewer. As we have seen, change can be carefully managed throughout the project through a single source of truth for manufacturing data. The features we have seen in the demonstration can be adopted at once or incrementally by designers. Quick recap of the workflow we've just seen. Changes can be effectively managed without disruption to an organization's workflow by assigning work and automatically managing and tracking the changes made to the ship. The work carried out under a task, such as the creation of parts and nests, can be used to feed downstream PLM and ERP systems if required. Throughout the design lifecycle, we need to reuse designs and capture changes wherever possible to reduce costly rework. Tracking of changes and the ability to transfer those changes to different configurations at a part level minimizes the risk of change. You can take the worry out of shipbuilding change by implementing an efficient change management system for knowledge management, enable capture, management, and reuse of relevant design and product knowledge throughout the change process. Change propagation. Ease the identification of change propagation and aid in decision making and help maintain the design integrity. Collaboration. Ensure that the right information is available to the right person at the right time throughout the extended enterprise. Information interpretation. Provide both textual and graphical information in a way that is easily interpreted by anyone involved in the process. And reduced cost overruns by improving the management of risk. Back to you, Greg.
Thanks, Simon. Yeah, thanks, Simon and Malay, for giving us that detailed look. Now we've asked you to ask questions. We've had some come in. We want to know what your change management challenge is. If you didn't reach out today in the questions, make sure to contact us and let us know, and we can get back to you about your specific situation, how you can advance your own change management workflows. So here's a question for Malay from Peter. Change can be soft or hard. Can you enlighten us on what the difference is in this case?
Yeah, that's a good question. And we are talking about engineering change management here. Typically, soft change is something which affects the organization. That is, how do you make an organizational change or make the teams adapt to a new system or process? That's soft change. And hard change is which is typical and implemented in a tool. So we're talking about engineering change management. So it is essentially a hard change. But then once you implement engineering change management tool, whichever tool you use, then the team has to start using that tool, so that the relearning of the team and the using the tool will be a soft change. So, right?
Thanks, Simon. I think this is a question for you from David. Who should lead the change within a shipyard?
Thanks, David. Typically, we see a design authority and a design review panel, typically consisting of members from each discipline who would understand how that change affects their own department. The design authority leading this committee can coordinate with the relevant people and come up with a possible solution documented in an ECO, and then execute that change through the organisation.
Malay, I think this is a question for you. This is from Nikhil. In a conventional setup without a PLM or PDM software incorporated, how would you suggest change management be formulated and implemented?
Thanks, Nikhil. This is actually a very interesting question, because while change management is there in every shipyard or any design organization dealing with ships, they do have a change management process. May not be an automated, so the definite change is managed by the organization. The question is, without a PDM system, PLM, how to implement change. So while you do have a change process, what is necessary is actually a rigorous implementation of the change process. So firstly, you have to develop or decide on the strategies and techniques to implement change management in the organization. Some of the things which, for example, Simon talked about is establishing a change management board is one of those techniques. And then once you have defined a formal change management process, then encourage everyone in the organization and part of the organization to stick to the change management process. Initiate change, document change, manage change using the process. And based on the tools that you have, you may be using Word, you may be using Excel, you may be using email. So use those, you can start using those tools to make sure that the change management process is followed. And with time, you can look at other options that we are able to manage in this way. Let us see if our CAD system can handle a lot of change management tasks, then implement those change management tasks in the CAD system. Then you say, okay, we have covered this much, this step is done. Then let's see if we should look at a PDM system or a PLM system, which can now take this change management process across to the ERP of manufacturing. So this is the way to go. One is first to decide that we will follow a rigorous change management procedure, define the process, get the buy-in for the organization, and then step by step implement IT tools, which can take you forward and you start seeing results from early steps to more advanced steps of implementation.
I think we just have time for 2 more questions here. This question's from Nick. We are a 2D drawing heavy organization. Any recommendations for how to improve the fidelity or pull from 3D to 2D to enable these change management efficiencies? I'm not sure which one of you would like to answer that first.
I can jump on that one. I know that within Ship, there's a great tool, Marine Drafting, that generates 2D views from the common 3D product model that remain fully associated to that 3D view as updates occur. For an organisation with lots of 2D drawings, you could adopt a 3D system that does similar to that, or you could make sure you use external references and reference from common sources to ensure that drawing views and things remain consistent without having to update too many documents at once.
And here's just one final question from Terry. Terry says, would there be an advantage to have a product designed for life cycle change? A product able to accept change with minimal manual effort on the deck plates? So I guess Terry's question is it better to design for the change in advance? Yeah, Malay, do you have any comment on that?
Yeah, this is, I would say, more as a strategy that what type of designs we do, and sometimes design for change itself is a strategy which some organizations adopt. That means while we do the design, we consider what all changes could happen and keep a placeholder in the design for that. If you look at, I don't know whether we're entirely 100% correct, but if you look at the modular shipbuilding itself is in that direction. That means if you design different modules which can be combined together for different configurations of ships, we're essentially trying to ease the change process. The changes they're limited to the interface. As when interfaces are the same, you make internal changes, the interfaces are not affected. I think in my view, it could be similar to what you're talking about as an example. Yeah.
Terry said, yes, modular, thanks. Perfect. All right. Yeah, thank you guys for your questions. And thanks for listening in today as we kind of took you on this overview and detailed look at change management. Make sure to, if we didn't get to something you wanted to talk about, make sure to reach out to us, ssi.today/contact, or feel free to learn more on our website, our blogs, our Waveform blog run by our co-CEO, Dennis Moray, or the Crow's Nest blog by our co-CEO, Darren Larkins. Thanks so much for joining us today, and we'll see you next time.